Hello everyone. Today we are going to start our new lesson, chapter 6, class 10. The next topic is Coulomb's law. What is Coulomb's law? Coulomb's law is a law discovered by Charles Coulomb, a French physicist, in the year 1785. So he was a French scientist, and he gave the relation between two charge, and he says that there exists an electrostatic force between two charge. He says that any 2 points charges exert an electric force on each other that is proportional to the product of their charges and inversely proportional to the square of the distance between them. If you remember, you have studied in your previous classes the gravitational law of gravitation, which was given by the Newton. According to Newton, he says that in any two objects in this universe, they exert forces on each other, and those forces is directly the magnitude of the force is directly proportional to the mass of the two objects and inversely proportional to the square of the distance between these two particles, between these two masses. But likewise here, the Coulomb's law also says that if there are two charges, if these two charges are brought near to each other, they will exert electrostatic force on each other. Okay, this charge will exert electrostatic force on this charge, and as a result this charge will also exert electrostatic force on the charge respectively. The magnitude of this electrostatic force is equal to the product of the charges between these two charges. Okay, so and inversely related related to the square of the distance between these two. So if there is a greater distance, the electrostatic force will be lesser, and if the distance between these two charges is lesser, the electrostatic force would be greater. So according to Coulomb's law, force is directly proportional to the product of two charges, and force is also inversely related to the square of the distance between these two charges. So combining these two relation, we will get that force is directly proportional to the product of the charges, okay, to the product of the charges, and inversely related to the square of the distance. So in order to remove this proportionality sign, we always keep a constant term, and this constant term is k over here. What is k? K is as the constant, and it is equal to 1 over 4 pi epsilon naught. So where epsilon naught is known as the permittivity of free space, that is the Greek epsilon. The value of epsilon naught is approximately 8.85 into 10 raised to power minus 12 picometer. Picometer means 10 raised to power minus 12. An equation for the law of Coulomb's law would be F is equal to Q1 into Q2 divided by 4 pi epsilon naught r square. Okay, so this is the overall equation for the electrostatic force between two charges. By substituting the values of pi and epsilon naught, we can find that the force can also be given by the equation. So this force is equal to 9 into 10 raised to power 9 Q1 multiplied by Q2 divided by r square. So this numerical value is 9.0 into 10 raised to power 9 Newton per meter square per Coulomb square. Let's do example. The example that a helium nucleus has charge of plus 2e. Okay, there is a helium nucleus and its positive charge is plus 2, and a neon nucleus having 10 protons, where E is the quantum of charge. So E is the quantum of charge, and the charge value, we know that it is a constant value, that is 1.6 into 10 raised to power minus 9 Coulomb. Find the repulsive force exerted on one of the other when they are 3.0 nanometers. So here charge on the helium is +2. So you need to multiply +2 with 1.6 into 10 raised to power minus 19 Coulomb. Keep in mind this is the charge value for a single charge, and when it comes +2 you have to multiply with this 1.6 with 2, and that of neon is 10. Neon have 10 proton, 10 into 1.6 into 10 raised to power minus 19 Coulomb, and the distance between these two charges is 3.0 nanometer, or we can say 3.0 into 10 raised to power minus 9 meter, because nano is equal to 10 raised to power minus 9. So we will put the value in the according to Coulomb's law. F is equal to this is the value, constant value, multiplied with the product of charges divided by the square of the distance. By putting the value, we will get the electrostatic force between these two, between neon and helium, is 5.1 into 10 raised to power minus 19 Newton, or 0.51 nano Newton. Another example is two coins lie 1.5 meter apart on a table. They carry identical charges. Approximately how large is the charge on each if a coin experiences a force of 2 Newton? So the diameter of the coin is small compared to the 1.5 meter separation. We may therefore approximate the coins as point charge. So we will consider the coins as charge, okay? And both of these coins, they are electrified. They are being charged electric, okay? And the distance between them is 1.5 meter. So force is given. Force is 2 Newton. We have to find the charge. Now, according to the Coulomb's law, F is equal to K Q1 multiplied by Q2 divided by R square. By putting the value, we get the product of charge. Product of charge is equal to 5 into 10 raised to power minus 10. And product of charge, so we multiply this both these charges, and it will become Q square. So Q square would be equal to 5 into 10 raised to power minus 19. Taking square root of this value, we will get 2 into 10 raised to power minus 5 Coulomb. So I hope that you have understood the concept. Do study and stay blessed and happy.